Then there's another category of naming that we need to learn, and that's acids. So acids are molecular compounds. They are formed from nonmetals, and when you put them into water, when you dissolve them in water, they form ions, but when they're not in water, they do not contain ions. So they're not actually ionic compounds, but they ionize, they form ions. We can recognize acids in their formulas because in this class, they will always start with H. If it starts with H, it's an acid. So we put acids into two groups. One they call binary acids, and it says it contains only two elements. That's a little bit of a lie. I prefer to think of there as the oxyacids. Those do contain oxygen. And if it doesn't have oxygen, then it's the other kind. So I would prefer to call them oxyacids and other kind acids. But the book calls them binary. So we'll learn about naming the binary acids first. So this is where you've got two elements, hydrogen and a nonmetal. So like HCl, HBr. You've got hydrogen and one other nonmetal element. So you put the prefix hydro on the front, and then you take the base name of the nonmetal, and you change the ending to ic, and then you put the word acid on the end. So this is HCl. We take Cl, chlorine, and we go hydrochlor, but instead of ene, chloric acid. Hydrochloric acid. So this is hydrogen and chlorine as an acid. HBr, hydrobromic acid. What if you need to write the formula from the name? Let's do one. I'm probably duplicating a slide that's coming up, but oh well. Hydrofluoric acid. Well, what are the two elements in that? Hydrogen and fluorine. So a great guess would be HF, and you'd actually be correct there. Are they always one of each? No. So this forms an ion, this forms ions, and what ions does it form? Well, hydrogen forms a +1 ion, and fluorine forms a -1 ion. We've learned how to predict that. So we know that this is one of each, just HF and not H2F or something, because these charges match up. Told you. That's okay. We're going to write the formula instead for hydrosulfuric acid. So we're going to write the formula for this. Hydrosulfuric acid. What are the two elements in there? Hydrogen and sulfur. So to find the formula for this, we think about, well, what ions does it form when you put it into water? What's the charge on the hydrogen ion? +1. And on sulfur? -2. So how many hydrogens need to be with this sulfide? 2. So the formula for that is going to be H2S. And you'll notice that it was just sloppy. It's good. Isn't that better? H2S. Now it kind of looks like a Z, but we'll get over it. You'll often see this AQ, because technically if it's dissolved in water, it's named as an acid. If it's not dissolved in water, then it's named as a molecular compound. And we're not going to go there. We're just going to name these as acids. How would we name this one, H2SE? Hydro. So it's selenium, right? So selenic acid. So this This is selenium, so we change the end of selenium to selenic acid. Any questions? Yes?
How, because some polyatomic ions start with H as well, how do you not confuse them with acids?
That's a good question. So if you had something like not that. HPO4, 2 minus, is a polyatomic ion. Why don't we name that as an acid? Because it has a charge on it. So this one doesn't have a charge on it because it's a compound. This has a charge on it because it's an ion, which would be part of a compound. Okay?
Will it always have the charge identifier?
The formula, if you leave the charge off, it becomes something completely different. Okay, so the other kind are the oxyacids, and as the name suggests, these have oxygen in them. So the oxyacids contain oxyanions. Those are the polyatomic ions that we've been talking about. So we look at this HNO3. There's the H that tells us this is an acid. Cover up the H and look at what's left. NO3. That should remind you of nitrate ion. Nitrate ion has a charge. This doesn't have a charge. It's got a hydrogen in front of it. But when you put this into water, it separates into hydrogen ions and nitrate ions. H2SO3. Cover up the H's that make it an acid, SO3. SO3 2 minus. It has 2 hydrogens because it needs 2 of them to even out the charge. So this is 2 hydrogens, H plus and H plus, and the SO3 2 minus. And you put all those together and their charges add up to 0. The number of hydrogen ions in the acid formula depends on the charge of the oxyanion. So if the charge is 2, the number of hydrogens is 2. So H2SO4, cover up the H's, SO4, that's the sulfate ion. Okay? The names of these acids are going to be based on the names of the oxyanions that are in them. That's why we need to be able to recognize this. So the name is based on the name of the oxyanion, and we change the ending of its name and add the word acid. So if it has an ion that ends in "ite," so that could be hypochlorite or it could be chlorite, it's going to change the "ite" to "us." So hypochlorous or chlorous acid. If it ends in "ate," you change the ending to "ic." Notice there's no hydro at the beginning. You just change the name of the oxyanion and stick the word acid on it. So if we look at these acid formulas, they all start with H, and they all have oxygen in them. These are all oxyacids. So when you name this, cover up the H and look at what the other thing is. NO2. NO2 is nitrite ion. You change the "ite" to "us" and add the word acid. Oh, I don't have it in here. So how do you remember that? "Ite" and "us," "ic" and "ate." Rick ate him before he could bite us. Okay, Rick ate him before he could bite us. I don't know what kind of a thing he is or Rick is, but maybe Rick's a dog. And he ate the rat before he could bite us, something like that. Anyway, "ic" and "ate." I know I'm going over. I started late. "Ite" and "us." If you need to leave, go ahead and leave. I'm going to stop soon. "Ic" and "ate," "ite" and "us." Okay? So you look at the formula and you identify the name of the polyatomic ion that's in there, the oxyanion. So SO4, that's sulfate. You change the ate ending to ic and add the word acid. Now, a weird thing happens with phosphorus and sulfur, the UR comes back. Not sure why, won't try to trick you on that one. So let's name this one, HNO2. What's the ion in there? Nitrite. It was a little bit of a guess, but you got it. So, ite changes to what? Yep, so we get rid of that, and we replace it with us. So, nitrous acid. Well, HClO4. Cover up the H. What's that?
Chloride.
Chlorate's a good guess. This has an extra oxygen. Perchlorate. So this is a perchlorate ion in there. So we change 8 to what? Ick. Another one is the white mouse ate icky cheese. Perchloric acid.